Emergency power system duration is dictated by several codes. Firstly, NFPA 110, Standard for Emergency and Standby Power Systems, specifies a minimum of 2 hours for emergency power systems. Secondly, the Elevator Code, NFPA 17.1, requires that elevators operate for at least 30 minutes during a power outage. When determining the appropriate fuel tank size for a diesel generator serving life safety systems like elevators and emergency lighting, it's essential to consider all applicable codes. The International Building Code Section 1006.3 mandates that emergency lighting be powered for a minimum of 90 minutes. However, this might not be the only requirement. NFPA 110, a widely adopted standard for emergency and standby power systems, often requires a minimum of 2 hours of runtime. This means the fuel tank must be sized to support the generator's full load, including elevators and lighting, for at least this duration. Ignoring NFPA 110 could lead to an undersized fuel tank and potential code violations. If the emergency lighting is removed from the generator's load and replaced with battery packs, the situation changes. In this scenario, the elevator code becomes the primary driver for fuel tank sizing. NFPA 17.1, the safety code for elevators and escalators, mandates that elevators have the ability to operate for a minimum of 30 minutes during a power outage. Therefore, the generator and its fuel tank must be sized to provide sufficient power for the elevators for at least 30 minutes. It is important to understand the implications of removing the emergency lighting load. While it might seem like a way to reduce the fuel tank size, it shifts the emphasis to the elevator code. You must carefully calculate the power consumption of the elevators and ensure that the fuel tank can support their operation for the required duration. Always consult with relevant authorities, such as the fire marshal and elevator code official, to confirm the specific requirements in Minneapolis and to ensure compliance with all applicable codes and standards. The owner's desire for code minimum should be carefully balanced against the potential risks and liabilities associated with an undersized fuel tank. It is generally advisable to err on the side of caution and provide a buffer for unexpected power demands or extended outages. The process of sizing a diesel generator fuel tank for life safety systems involves several key steps. 1. Determine the total load. This includes all equipment connected to the generator, such as elevators, lighting, and any other essential systems. Obtain accurate power consumption data for each device to calculate the total load in kilowatts. 2. Consider the code requirements. Identify all applicable codes and standards that dictate the duration of emergency power, such as IBC 1006.3, NFPA 110, and NFPA 17.1. Use the most stringent requirement as the basis for fuel tank sizing. 3. Calculate the fuel consumption rate. Determine the generator's fuel consumption rate in gallons per hour at the calculated load. This information can typically be found in the generator specifications or obtained from the manufacturer. 4. Calculate the required fuel tank capacity. Multiply the fuel consumption rate by the required duration of emergency power to determine the necessary fuel tank capacity in gallons. For example, if the generator consumes 10 gallons per hour and the required duration is 2 hours, the fuel tank should have a capacity of at least 20 gallons. 5. Add a safety margin. It is recommended to add a safety margin of 10 to 20% to the calculated fuel tank capacity to account for variations in fuel quality, generator efficiency, and unexpected load increases. This margin ensures that the generator can operate for the required duration even under adverse conditions. 6. Select the appropriate fuel tank. Choose a fuel tank that meets all applicable codes and standards, such as UL 142 for above-ground tanks or UL 58 for underground tanks. Ensure that the tank is properly sized, vented, and equipped with appropriate safety features. 7. Install and maintain the fuel tank properly. Follow the manufacturer's instructions for installation and maintenance. Regularly inspect the tank for leaks, corrosion, and other damage. Implement a fuel management program to ensure that the fuel is properly stored and handled. The NEC, or National Electrical Code, does not specifically dictate the duration of emergency power for diesel generators. However, it provides requirements for the installation and wiring of emergency power systems, which can indirectly affect the fuel tank sizing. For example, NEC Article 700 covers emergency systems and requires that they be designed and installed to provide power automatically to essential loads within 10 seconds of a power outage. This requirement necessitates a reliable fuel supply and a properly sized fuel tank. Additionally, NEC Article 701 covers legally required standby systems, which are similar to emergency systems but serve loads that are not necessarily life safety related. These systems also require a reliable fuel supply and a properly sized fuel tank. Understanding the different types of emergency and standby systems is crucial for determining the appropriate fuel tank sizing. Emergency systems are intended to provide power to life safety loads, such as emergency lighting, fire pumps, and elevators. Legally required standby systems serve loads that are required by law, such as ventilation systems and communication systems. Optional standby systems provide power to non-essential loads, such as convenience outlets and HVAC systems. Fuel tank sizing should be based on the total load of all connected systems, with a higher priority given to life safety loads. The selection of a diesel generator for life safety systems involves several considerations. Firstly, reliability. Choose a generator from a reputable manufacturer with a proven track record of reliability. The generator should be designed and tested to meet the rigorous demands of emergency power applications. Secondly, fuel efficiency. Select a generator that offers good fuel efficiency to minimize fuel consumption and reduce the required fuel tank size. Compare the fuel consumption rates of different generators at various load levels to make an informed decision. Thirdly, emissions compliance. Ensure that the generator meets all applicable emissions regulations. Diesel generators can emit pollutants such as particulate matter and nitrogen oxides, so it's important to choose a model that minimizes these emissions. Fourthly, noise level. Consider the noise level of the generator, especially if it will be located in a noise-sensitive area. Look for generators with noise reduction features, such as sound attenuating enclosures. Fifthly, maintenance requirements. Evaluate the maintenance requirements of the generator, including the frequency of oil changes, filter replacements, and other routine maintenance tasks. Choose a generator that is easy to maintain and has readily available spare parts. Sixthly, automatic transfer switch. Use an automatic transfer switch, or ATS, to ensure a seamless transition between utility power and generator power in the event of an outage. The ATS should be designed and tested to meet the requirements of NEC Article 700. Seventhly, remote monitoring and control. Consider a generator with remote monitoring and control capabilities. This allows you to monitor the generator's performance, receive alerts in case of problems, and remotely start or stop a generator. Eighthly, parallel link capability. If you anticipate the need for additional power in the future, consider a generator with parallel link capability. This allows you to connect multiple generators together to increase the total power output. The maintenance of a diesel generator and its fuel tank is essential for ensuring reliable operation during emergencies. Regular maintenance tasks include inspecting the fuel level, checking for leaks, changing the oil and filters, testing the battery, and running the generator under load. The fuel tank should be inspected for corrosion, leaks, and proper venting. The fuel should be tested periodically to ensure that it is free of contaminants and has not degraded. A comprehensive maintenance program should be developed and followed to ensure that the generator and fuel tank are always ready to operate. Proper ventilation is crucial for diesel generators and fuel tanks. Diesel generators produce exhaust gases that can be harmful to human health. The generator room should be properly ventilated to remove these gases and provide fresh air for combustion. Fuel tanks also require ventilation to prevent the buildup of pressure and the release of flammable vapors. The ventilation system should be designed and installed to meet all applicable codes and standards. Proper grounding is essential for the safety of diesel generators and fuel tanks. The generator and fuel tank should be properly grounded to prevent electrical shock and reduce the risk of fire. The grounding system should be designed and installed to meet the requirements of NEC Article 250. Regular inspections and testing are critical for ensuring the reliability of diesel generators and fuel tanks. The generator should be inspected regularly for signs of wear, damage, or corrosion. The fuel tank should be inspected for leaks, corrosion, and proper venting. The generator should be tested under load periodically to verify its performance and ensure that it can provide power for the required duration. A qualified technician should perform these inspections and tests. The installation of a diesel generator and its fuel tank should be performed by qualified professionals. The installation should comply with all applicable codes and standards, including the NEC, NFPA 110, and local building codes. The installer should be familiar with the specific requirements for diesel generators and fuel tanks and should have the necessary experience and training to perform the installation safely and correctly. The location of a diesel generator and its fuel tank should be carefully considered. The generator should be located in a well-ventilated area that is protected from the elements. The fuel tank should be located in a secure area that is protected from damage and vandalism. The location should also comply with all applicable codes and standards. The permitting process for a diesel generator and its fuel tank can be complex. It is important to obtain all necessary permits before beginning the installation. The permitting process may involve submitting plans and specifications to the local building department, fire department, and environmental protection agency. The permitting process can take several weeks or months, so it is important to start the process early. The cost of a diesel generator and its fuel tank can vary depending on the size, features, and installation requirements. It is important to obtain multiple quotes from different vendors before making a decision. The cost should include the generator, fuel tank, automatic transfer switch, installation, permitting, and ongoing maintenance. The financing options for a diesel generator and its fuel tank may include leasing, purchasing, or a combination of both. Leasing can be a good option for businesses that want to avoid the upfront capital cost of purchasing a generator. Purchasing may be a better option for businesses that plan to keep the generator for a long period of time. The warranty for a diesel generator and its fuel tank should be carefully reviewed. The warranty should cover defects in materials and workmanship and should provide for repair or replacement of the generator or fuel tank in the event of a failure. The warranty period should be long enough to provide adequate protection against potential problems. Training is essential for personnel who will be operating and maintaining a diesel generator and its fuel tank. The training should cover the operation of the generator, the maintenance requirements, the safety procedures, and the troubleshooting techniques. The training should be provided by a qualified instructor. The safety considerations for a diesel generator and its fuel tank are paramount. The generator and fuel tank should be installed and operated in accordance with all applicable safety codes and standards. Personnel should be trained in the proper safety procedures. The emergency procedures for a diesel generator and its fuel tank should be clearly defined and documented. The emergency procedures should cover events such as power outages, fuel spills, fires, and other emergencies. Personnel should be trained in the emergency procedures. The regulatory requirements for a diesel generator and its fuel tank can be complex and vary depending on the location. It is important to understand all applicable regulatory requirements before installing and operating a diesel generator and its fuel tank. The regulatory requirements may include environmental regulations, safety regulations, and building codes. The environmental considerations for a diesel generator and its fuel tank should be carefully considered. Diesel generators can emit pollutants that can harm the environment. It is important to choose a generator that meets all applicable environmental regulations. The fuel tank should be properly designed and maintained to prevent fuel spills. The sustainability aspects of diesel generators are increasingly important. Consider using biodiesel or other alternative fuels to reduce the environmental impact of the generator. Implement energy efficiency measures to reduce the generator's fuel consumption. Explore renewable energy sources as a potential alternative to diesel generators. The future trends in diesel generator technology include increased efficiency, reduced emissions, and greater integration with renewable energy sources. Diesel generators are becoming more sophisticated and reliable, making them an increasingly attractive option for emergency power and standby power applications. The integration of diesel generators with smart grid technologies is also becoming more common, allowing for more efficient and reliable power distribution. The specific requirements in Minneapolis may differ from the general requirements outlined above. It is important to consult with local authorities to confirm the specific requirements for your project. The local building department, fire department, and environmental protection agency can provide guidance on the applicable codes and standards. The cost of compliance with these requirements should be factored into the overall project budget. Regularly review and update your emergency power plan to ensure that it remains effective and meets the changing needs of your facility. Conduct periodic drills to test the effectiveness of the plan and identify any areas for improvement. Maintain accurate records of all maintenance and testing activities. Communicate the plan to all relevant personnel and ensure that they are properly trained. By following these steps, you can ensure that your diesel generator provides reliable emergency power for your life safety systems and that you comply with all applicable codes and standards.